Now we look at a problem given as a body starts from rest and travels a distance s with uniform acceleration. So it is traveling a distance s with uniform acceleration, then moves uniformly a distance 2s. That means it is not moving with acceleration now, it is moving with the velocity whatever required for a distance 2s. Then it is coming to rest after moving further 5s under uniform retardation. That means the body is accelerated first, remaining same, then decelerated. Find the ratio of average velocity to the maximum velocity. That means if at all I take the graph, here whenever I write the velocity time graph over here, then initially it is traveling with acceleration and reaching to the maximum velocity. Final velocity is the maximum velocity, and later in the second interval of time it is traveling with uniform velocity. That means there is no acceleration over here. Then again it is coming down with uniform retardation. That means starting with rest and finally reaching to the rest condition only. In between there are 3 intervals where in the first time it is traveling with acceleration, in the second interval it is traveling with the uniform velocity, in the third interval it is traveling with the uniform retardation. Therefore, we have a concept like the area under velocity time graph gives rise to the displacement. Therefore, I can write a VT graph based upon the data given. Here, the first interval it is reaching to maximum velocity, then continuing with the same velocity, then coming to the rest. That means the first interval distance or displacement traveled is given as S. Therefore, in the first interval, S1 is equal to area under this triangle, because area under the VT graph gives rise to the displacement. And this S1 is given as S. That is the reason S is equal to half base into height. Base is the time, height is V maximum. Therefore, I can write the S as half T1 into V maximum. Let us say that is the first interval equation. Similarly, coming to the second interval, it is a rectangle. Then area of the rectangle is nothing but the distance travelled in the second interval. That is given as 2s. Therefore, 2s can be written as this much, area of the rectangle. Let us say the equation 2. Then coming to the third interval, here it is traveling with retardation and travels a 5s distance. Therefore, 5s is equal to area of this triangle giving rise to half T3 V maximum. Let us say that is third equation. In the problem, the question asked is to find out the average velocity to the ratio of average velocity to the maximum velocity. Therefore, from the definition we know that average velocity is given by total displacement traveled divided by the total time. Therefore, total distance traveled is nothing but S in the first interval, 2s in the second interval, 5s in the third interval. Therefore, total displacement is nothing but 5 plus 2 plus 1, 8s. That is 8s over here. And the time, first interval time I can calculate from the first equation. Simplifying this, T1 is equal to 2s by V maximum. That is 2s by V maximum. And here it is coming to be 2s by V maximum again here also. Then coming to here it is 2 into 5, 10s by V maximum. Then simplifying this, you are getting the V average to V maximum as 8s by 14s. SS will get cancelled and coming rise to the 4 by 7. Therefore, V average is to V maximum is nothing but 4 is to 7. That is going to be the answer for this problem.